Hi, this is part 7 of the lecture material for week 1 of CS 1030. So we've been talking about pseudocode, and what I'd like to do today, or in this video, is to add a new construct to the constructs we've already seen. So I'm going to start off by looking at a piece of repetitious pseudocode. So what is this code doing? It first sets the variable number to 1, and then we can see the rest of the code here repeats the same 2 lines of code, these 2 lines, 3 different times. So let's look at how that plays out. So this line of code, the first time we execute this content, sets the variable square to number times number. Number times number is an expression, and we can evaluate it by looking up the value held in a variable number, giving us 1 times 1. We do the multiplication, and that results in 1, which is what we set square to. So square gets the value 1. Now we set number to number plus 1, and number holds the value 2 after this assignment, because the expression number plus 1 evaluated to 2. So in that case, square gets set to number times number, which is 2 times 2, which becomes 4. So square holds the value 4 now. This line of code, setting number to number plus number, sets number to 3, and so square gets set to 9. Finally, the last time we increment number, we set number to 4, and square gets the number 16. So is there anything wrong with this code? Well, not strictly speaking. I mean, we can do whatever we want in pseudocode. We can write any code, any algorithm we want, even if it's repetitious. But what if we, instead of repeating something 3 times, we had to repeat some sequence of actions, 200 times or 20 million times? That would start to be awkward. We don't want to do it. We would start to get a very difficult to look at program because it'd be so big, and we would have a lot of potential for error because we could make a typo somewhere in the repetition. So we don't like this kind of repetition taken to sort of extremes. So let's look at what we can do about it. The thing we're going to do about it is introduce a new pseudocode construct specifically for repetition called a while loop. And there's a number of different ways to do repetition, and this is sort of a relatively easy one. So the way we're going to understand a while loop is to look at how it works in the context of a small pseudocode program on the left side of the slide here. So let's see how this plays out. So the first line of code here is going to set count to 1. So what that does is takes a new variable called count and store 1 into it. The second part of the pseudocode program is the while loop. And now we need to understand how the while loop works. And basically what it's going to do at a high level is repeat an action while some condition is true. So let's look at how that works. And so we can break this while loop down into 3 different parts. The first part is the while keyword. It's just the word while here. And all that does is tells us, the people reading the pseudocode, that this is a while loop. The second part of the pseudocode, the second part of the while loop is the condition. So the condition is a part in parentheses here in the blue oval, and a condition is just, again, as we talked about in the previous lecture, it's just an expression which has to always evaluate to either true or false. So it's a Boolean expression, and then the third part of the while loop is the action part of the while loop. The action part is simply a sequence of lines of pseudocode. So it's lines of pseudocode, whatever we want to write here, we can write. And how we can tell what's part of the action, how we can tell what's part of the action part of this is because it's indented out. So the 2 lines of pseudocode in the blue oval here, following the line with the while, is the action part of this while loop. And then those are going to execute while the condition is true. And then the last thing here, the displaying done, that is not indented. It's not part of the action. It's not part of the while loop at all. That's simply another line of pseudocode in our program that follows the while loop. So that executes unconditionally if and when the while loop finishes executing. Okay, so now that we have seen what a while loop looks like and we've seen the parts of it, let's look at how it actually works. So the way a while loop works is when we get to a while loop, we evaluate its condition. So the condition is always going to either be true or false. And if it's true, we're going to execute the action. And then we're going to go back and do the same thing again. We're going to evaluate the condition again. If it's true, we evaluate the action a second time. And we just keep going. So if the condition of a while loop never becomes false, our program basically just hangs up here. It's what we call an infinite loop. The while loop never stops. But as soon as the condition becomes false, so as soon as we evaluate the condition and it's not true, we're done with the while loop. We don't execute the condition another time. We don't execute the action another time. We instead go to displaying done. And the same thing, the same dynamic, jumping over the action, would be true even the first time we hit the while loop. So, so the while loop, in summary, executes its action either 0 times, or 1 time, or 2 times, or many times, or possibly an infinite number of times. So let's look how that plays out in the program here. So count is 1, and now we are going to execute the while loop. So we evaluate the conditional expression, count less than or equal to 10. Since the variable count holds the value 1, we get 1 is less than or equal to 10. And from math, we know that that's true. So the expression is true. And since the expression is true, since the conditions, the while loop's controlling expression is true, we execute the action. So we display count, so we would display 1. And then we're going to set the value of count to count plus 1. So this basically just increments the value of count to the next higher integer. So now count becomes 2. So if we want to play this out, let's talk about where it stops. Let's talk about how many times this executes. So what's the highest number that will be displayed to the user? And the execution of this while loop for values of count like 2 and 3 and 4 is sort of boring. But it gets more interesting as we get closer to 10, because we need to figure out exactly what happens when we reach the point where the condition becomes false. And that's what we call the termination condition for the loop. It's the thing that has to happen before the loop stops executing. So the while loop stops executing when count is equal to 11, but let's just sort of play that out. So we display 1, 2, 3, 4, 5, 6, 7, 8, and let's jump to 9. So we display 9, which is the current value of count. We set count to count plus 1, so set count to 10, and now we evaluate the expression one more time. So the question is 10 less than or equal to 10? And again, from math, we know that that's true. So we display 10, we set count to count plus 1, so now count is 11. We go back to the start of the while loop, which is what we always do when we get to the bottom of the action. And we ask, is 11 less than or equal to 10? It's not. So since that's false, we basically exit the while loop at this point. We don't execute the action any more times. We jump to the next part of the pseudocode following the while loop, and we just display done. So the last number displayed by this program is 10. Although, and this is kind of tricky and confusing, the last value held by the variable count in this program is 11. So if I asked you what's the highest number this will display, or if I asked you what's the highest value held by count as this program executes, those would be different. And it's really, really easy to get confused about stuff. It's really, really easy to believe that a loop terminates one iteration before or after it actually terminates. And this is so common to sort of be a little bit wrong about these things when looking at a program, that we have a name for this in computer science. It's called an off by 1 error. And off by 1 errors are sort of the bane of programmers' existence. They're horrible because they're just hard. And I'll just tell you right now that you never grow beyond making mistakes like off by 1 errors while you're programming. I mean, I still make these mistakes all the time when I write code. And so what we want to do is just basically learn to recognize the potential for danger while writing something like a while loop. We want to make sure it stops exactly when we want, and not one before or one later. And we also want to make sure it stops at all. If we have just a typo in here, where for example, we forget to increment count, then the condition will never become false, and the program will just hang at this point. So we don't really want that to happen either. So in summary, the while repetition construct has 3 parts. There's the keyword, there's the controlling condition for the loop. It's a Boolean expression or a conditional expression. And then there's the action, and the action gets executed 0 or more times as part of executing the while loop in pseudocode. So this is pretty important. There's a lot to bite off here, and we're going to spend more time going through this, but creating code that actually works with repetition and selection that we looked at in the previous lecture, this is fairly hard stuff, and it's going to take a while to get on top of it. So let's work an example. So we're going to write an algorithm, and what we want the algorithm to do is print at the end the sum of all the integers from 1 to 10. So the sum of all integers from 1 to 2 would be 3, right? Because the numbers from 1 to 2 are 1 and 2, and we add them together and we get 3. We want to write a computer program that sums the integers from 1 to 10. And so there's a trick we're going to use here that is important, and we use it an awful lot while programming. And so I want you to just sort of start internalizing it and start getting used to it, we're going to have two different variables in the program that we write, in the algorithm that we write. One of them is going to count up from 1 to 10, and the other one is going to keep a running total of the sum. So the variable that's holding the sum is not going to hold the correct value at the start of the program because it hasn't done anything yet, and it's not going to hold the correct value while the repetition construct is executing. It's only going to hold the correct value, the sum of the numbers 1 to 10, at the end. And anyway, so like I say, this trick is the trick here is to separate out these two values, is to make this distinction between something we're trying to compute and then a counting variable, which is counting how many times we're going to execute some sort of a loop. So what I'd like you to do is pause the video for a minute and see if you can write pseudocode doing the thing at the top of the slide, doing this first bullet, sum the integers from 1 to 10. Okay, hopefully you had paused the video and wrote something down, like on a piece of paper near you. So let's look at my algorithm for this, and hopefully I got it right. So the way I would do this is I would set count to 1, then I set sum to 0. So sum is going to be the running total of the sum of the integers that we're adding up, and we want to start that sum at 0 because we haven't added anything to it yet. Now we're going to use a repetition construct. We use a while loop. And so we're going to say while count is less than or equal to 10, set sum to sum plus count. So count is counting from 1 to 10, and we want to add the current value of count to sum. And if we do that for every value of count from 1 to 10, then we can see that at the end of this program, it's going to be, sum is going to contain the correct thing. So the other thing we need to do in our while loop, and we can't forget to do this, is set count to count plus 1. We need to increment count so that the next time through the while loop, count holds a different value, so we can add that into sum. And again, if we forget to do that, we get an infinite loop, and our program just sort of hangs up, and that's not what we wanted to have happen. So when sum reaches 11, or sorry, when sum reaches, when sum reaches 11, the condition becomes false, and we display sum. But the important thing is that 11 didn't get added to the 11 didn't get added to sum. So this should be correct. And if we had a computer that could run pseudocode, it would print the correct answer. And I hope you got something like this. So if you didn't get this particular program, that's not a problem because there's a lot of different ways to do this kind of integer summation thing. And if you didn't get this at all, that's not a problem either, because this sort of idea of factoring out the work of the program into multiple variables and then using repetition constructs over those variables, this is fairly hard stuff. This is really the core of what we're doing here. We're going to spend a lot of time looking at how to do it, and that's why you're here. So if this didn't seem easy or intuitive to write this down, then you're absolutely not alone. It's probably almost everybody in the class is in that position. And our job here this fall is to try to train you up in this sort of key skill. This is sort of really kind of the core of programming, is taking a high-level task that you need to do, like summing up these integers, and breaking it down into these small steps. And none of these individual steps solves the problem, right? They work together to solve it. And that's sort of the essence of programming, is dividing complicated tasks into simple steps and using them to solve a problem. And it's hard, right? It's hard. I have trouble with this. Everybody who writes programs has trouble with it. It's frustrating. And we just have to kind of take baby steps and approach this a little bit at a time. So at this point, we've looked at variables assignment, input and output, selection in the previous lecture, and then in this lecture segment, we looked at one particular repetition construct, the while loop. There's other ones, but this one is good enough for now.